Hi, I'm Jain, and the goal of my project was to simulate the spread of COVID-19 through my high school DuPont manual. Due to many false negative tests and a large number of asymptomatic cases, we don't have a real idea of what COVID-19 spread is actually like, and this brings the need for an actual estimate. I created a Java simulation to model a full semester of school with over 2,000 students using a series of algorithms detailed on the slides that were developed using my own mathematical solutions to represent the manual school day. The class diversity algorithm, using a concept I call strong points, created schedules with students having more or less classes with the same students based on a variable called class diversity. A bus initialization algorithm used geometric probability to influence the number of students a student was exposed to on the bus based on the variable bus exposure. Class and lunch exposure algorithms created exposure seating arrangements based on the input variable class exposure and reasonable estimates. The exposure algorithm uses the input variable spread factor and safety to determine the chance COVID will spread from one student to another, accounting for masks. Lastly, the testing algorithm returns a positive case as positive with the probability based on the input variable false negative. Along with numbers on how many students were positive at all, each simulation also outputted data on how many cases were tested positive. This data was compared to the real tested positive data to determine if a simulation succeeded or not. After running over 250,000 simulations, one perfect set of variable inputs was determined that reliably matched real data. According to the perfect set, an average of 6.25 cases of COVID were spread daily, and 4.5% of the school, or 90 students, were infected on any given day. The perfect variable set showed the epidemiological concepts of growth, peaks, and immunity, indicating that the simulation was able to successfully model some disease through some school. However, without another estimate of total cases to compare it to, this simulation could not be evaluated as an effective model of COVID-19 through DuPont manual specifically, as assuming that matching positive test case numbers indicates matching total case numbers is flawed. For this reason, along with the introduction of the Omicron variant second semester, using the model for predictive purposes has no value, and it was concluded that the model only partially met the engineering goal. Thank you for your time.